piecewise functions. Here we go. So looking at a function and determining the domain and range, to figure out the domain, I want to see how far to the left it goes. And you see right here, that's as far as it goes, right here. It doesn't go any further to the left over here than what you see. So that is an open circle where x is -2. So therefore the domain is going to have a parentheses next to the -2 because it's not equal, and then it goes all the way through without any gaps. Even though it looks like a gap right here at 0, there's not because it's included right here. And the right barrier is right here where x is 4. It includes the 4, it's equal to the 4, so therefore it gets a bracket. The range, how low does it go? Well, right here on the x-axis, that's the lowest point, and that lowest point overall is almost but does not include 0. Then it exists all the way between, but right here where the y value is 3, that's the highest point and it includes that. So it gets a bracket on the 3. And that's domain and range, left to right, bottom to top. Now, it's going to take you a minute to copy this down, so go ahead and do it. Good job. So there's, a couple ways I can tell the function. So first of all, understand, here is my piecewise function. Boy, there's a lot to it, it seems like. But really, all there is to it, this is y, and this is function 1, function 2, and function 3. And here are the pieces of each function that we're taking. Down here, this is a table representing some points of this function. And what I'm asking you to do right now, Ms. Gilchrist, is tell me the value for f of 3. So that which I think we can figure out by looking at the table.
Yeah, I need to plug in 3. So if I come over here, here's my x value of 3. And so when I plug in 3, it looks like I get out 7.
The input of 3 gives me an output of 7. I can see that from the table.
That was easy.
For the record, if I had come in here to the function, this is where x is 3, so I would have plugged it into this x right here, and double check me, Ms. Gilchrist.
Looks like 7 to me.
4 times 3 is 12, minus 5 is 7.
And Mr. Osborne, I knew it was this piece and not this one because this one has the equal sign and the other one doesn't.
That's how we knew.
Beautiful. Okay, so now I got to plug in -1. So I need to come up here and figure out where -1 is. Let's see. Oh, the first one, yeah. Okay, so I'm going to plug -1 in. Ooh, Mr. Osborne, -1 squared. That's positive 1.
It is, and so if we're using our calculator, we're definitely doing the parentheses. And if we're not, we understand that this is multiplication, and I don't multiply before I do the exponent.
Right, so -1 times -1 would be positive 1. So we get 3 times 1 minus 1, which would be 2.
So f of -1 is 2. If I input 1 input leads to 1 output.
That's right.
All right, just a couple tips. All right, so a couple tips. If we're looking at this and we're looking at our matching activity, this one right here, that's going to be a horizontal line.
Yep.
So where you have y equals a number, that piece is going to be a horizontal line. Zero slope. Not going up, not going down. What about this one right here where it's kind of like 4x minus 5?
So since my x isn't squared, that's just a line with a slope.
And with positive slope, as a matter of fact. So I'll call it a positive line, right? That's y equals mx plus b. And then what about this one if I got a square here? What's that thing in there?
That makes a parabola. Like
Yes.
a U shape. Yep.
So those things might help you out. Just one more little pro tip. If you see a square root function, we'll get to this second semester, but it kind of looks like this.
Yep. Have fun matching.
Go Tigers.